Hi, hope you're all doing well. This is my game for my final year project. It's a demolition derby game in Unity. So it's just this racetrack here with some turrets which shoot at you. Just zoom in on those there, and these sniper towers as well, and these wrecking balls. So once they hit your car is going to be pretty seriously damaged. Yeah, so before starting the game, I guess one of the things I want to talk about is the actual car itself and how I made it in Blender. So it's made by hand in Blender. It took quite a long time to actually do. Actually, the only thing which wasn't custom made in this project are just these roads here and this shader for the car. I couldn't find any. I think that the standard Unity shader, it tends to not really show shadows very well in my opinion. So I guess having this nice toon shader, it really helped to show off the deformation a lot better. So yeah, these meshes are all pretty clean. So they're rectangular, and I couldn't find any nice car assets online, so that's why I just had to make my own, cause the ones which had low detail were not clean, and the ones which were clean, they just had too much detail, so that would be very slow for the game. And so in the plastic deformer class, I can set the properties of this frame. This frame is actually meant to be stronger than the actual panels around it. So as you can see, here's the class settings for that object. And so all objects have three main scripts. So it's this plastic deformer script. So this actually handles the actual deformation itself. Composite collider puts colliders on top of the deformation for real-time collision detection without using mesh colliders. So when you are using mesh colliders, you had to reset the entire mesh every time you wanted to sort of recalculate that collider's bounds, and that was very slow, even for small meshes. So I just had to make my own version of a mesh collider, and a collision handler. So this is just a script that basically takes in raw Unity collision data, and that just sort of presents it in a better way for the plastic deformer script. Yeah. So that's that there. Run the game. Actually, before I run the game, there's hinge joints and fixed joints all over the car. So I used hinge joints for just these doors and bits which can swing, and I used fixed joints for all the parts which should be fixed. So if I run it here, you'll know that it takes quite a long time for it to load, and that's because the composite collider needs to calculate the size of each box collider and also each of the strongly connected triangle pair polygons. And basically, if I had more time, I thought about serializing this and just storing the actual composite collider class inside of a text file. So you wouldn't really need to calculate it upon each start for the game, and you could just read from the text file. But I didn't have enough time to actually do that, but it was something small. And yeah, I can play the game here. As you can see, the car physics are pretty good. I'll try to get crushed by this, and yeah, as you can see, my car got hit pretty badly there on the side. I will show the car here. Yeah, here it is. And yeah, as you can see there, pretty big collision on the side, and this has a box shutter around it now because this door has actually fallen off. So when some body panel falls off, there's no need for there to be a composite collider or a plastic deformer one anymore. It's okay just to have a box slider on it. So there we go, and right here, yeah, and that door just fell off because it's not really connected to the car anymore. Oh yeah, so I'll try to get hit in the side here by this. Oh yeah, that's really nice. So as you can see there, car right on this side got hit pretty badly, and oh yeah, as you can see here, the wrecking ball hit around here, and you can really see the indentation. And basically, there's this part here hasn't really caught up with so this composite collider hasn't caught up with the shape of the mesh yet, because that was one other optimization feature, which was that you only need to update these box colliders only when enough box colliders really needed to be updated. So you don't really need to access and call that GPU on each frame, which really helped to speed up the game. That was one of the compromises which had to be made. Yeah, that's it there. I'll try to see if I can get hit in the front by one of the faster wrecking balls on the other side of the track. Oh, I just got hit there. Right, let's actually try to get hit in the front by this. Oh yeah, that door fell off. These tank shells don't do as much damage as the wrecking balls do, but it's still easy to see some deformation from them. Oh, as you can see there, the box sliders keep updating to have real-time collision detection on a mesh, which is changing due to the deformation, which I guess is the key sort of crowning aspect of this project for me. Also, another thing about the car is that if it gets too damaged, it's really hard to actually drive it, like here. So I'm gonna have to reset it there. Yeah. Here we go. Dodging all of these there. Yeah, because there were some really fast wrecking balls on the other side of the track. I want to see if I can show some good side deformation from those. Right here, those are the really fast ones. Those were some sniper bullets, by the way, which just went over the roof of my car. So I will try to park my car right here, see if I can get one of those to crash into me. Oh, just off by a small bit. Right there. So I see some pretty nice deformation on the top there. Yeah, as you can see, just wrecked the roof of my car. Um, Another thing I wanted to point out was you can see that the parts underneath, so parts underneath the mesh of us, so a mesh which is underneath another mesh also gets deformed by that mesh on top of it. So what you can see that this roof was actually pushing down on this frame, which caused this part of the frame to actually bend inwards, and now you can see it is clipping through the mesh, and that was that was the compromise that had to be made. So the faster that the Unity's physics manager runs, the more accurate this plastic deformation is going to be. The physics manager speed I'm talking about is actually here inside of the settings, inside the project settings, and bring it up here. So it's this time here, it's this fixed time step. I've got it set to 0.02 because that was the perfect compromise between the actual quality of the collision detection and then the optimization of the game. So I'll just keep running it here. Let's see if I can get hit in the side by one of them. Oh, close. Right there, right there. So you can see it's really crushing my car. You know, when that wrecking ball hit around here, you can see that it actually formed this nice crater on top of the car. And yeah, and if you look at it inside here, the crater is modeled, I guess, to an extent. Using the box colliders. So I'm going to keep running it there. The rear of my car is still pretty underformed at the moment. But I'm going to see if I can get a wrecking ball to actually hit it in the back. Probably this nice one over here. Oh, it hit the door, okay. And it deformed the door a little bit. Yeah. There we go, right there, as you can see. Zoom in on the car. Yeah, pretty serious damage to the car from that hit on the side there. Just destroyed the rear end. Also destroyed parts of the frame around here as well. So it works pretty well. It's just a bit slow, I guess. If I had more time to do this project, I would have worked on the actual speed of the game. It runs at around 60 FPS on my computer, and I think it ran around 45 FPS on my Mac. I'll actually try to see if I can do an entire lap without crashing, just to show the game. So these tank turrets turn, and oh no, my car got stuck on top of this thing here. Okay, I'll reset that. Yeah, so those tank turrets actually turn, and the turret itself turns on its y-axis, but the actual gun aims up and down, just like a real tank turret, which is something small. Yeah, here. Going around. No, these wheels are a bit glitchy, that they turn inside out every now and then, but didn't really know how to fix that. But it was just something small, so I just ignored it in a way. Oh yeah, the side of my car has already been hit. Oh, that was bad. As you can see, car got wrecked from that hit in the wrecking ball straight on the front there. And I guess it's a nice demonstration. You can see the crater that was formed by the wrecking ball when you go into the normal shade view. Just this nice crater. And I guess if you click on the car, you can see that this crater itself is actually modeled in colliders. So as if some other collider was to fall on top of this, it would accurately perform collision detection on the shape of the mesh. So that was the key part of this project, was getting those colliders to work. And yeah, this what also got hit in the side. I think that's where it got hit by the ball. And as you can see, the plastic deformer, it also works pretty well. It's pretty accurate. And yeah, so that's the project there. The actual physics itself was the hard part, and the game itself wasn't too hard. It was actually quite easy compared to the physics. Now my thoughts about the actual hardest parts, I guess, was part of getting that composite collider to work was actually trying HLSL code on the GPU, which was something that was completely new to me because I never tried graphics programming code before, and it runs on the GPU. It was pretty hard to actually set up. I think the first issue I had was I didn't know how to send 2D arrays into it, but I found that out eventually. And the second biggest issue was in HLSL, you don't have any of the Unity libraries such as transform point and transform direction and other neat matrix maths like that. So I had to make those functions myself for HLSL, so I needed to understand how all of those functions work.